Well, hello everyone. I'm Paul Deffenbaugh. I'm the editor-in-chief at Metal Architecture Magazine. Very glad you've joined us for another in our Metal Architecture webinar series. I hope everybody is staying cool. It's pretty nasty out there in some places. Today we're presenting a webinar on architectural insulated metal panels. What's next? It's brought to you by Centria. In just a moment, I'm going to turn things over to Brandon Kinsey. Brandon is going to field questions during the presentation. He has time allowed at the end of the presentation as well. So use that panel on your screen to submit the questions, and I'll raise them with Brandon at the right time. For those of you who are looking for certificates and AIA credit, that's all going to be handled automatically. Please give us 7 to 10 business days for us to process all that. We're also going to post a recording of the webinar on our website, so you can view it again and share it with colleagues if you want. You can find that at metalarchitecture.com/webinars. But right now, let me introduce Brandon Kinsey, who's the district sales manager for Detroit for Centria in the greater Detroit area. He oversees sales of projects from design through construction. Brandon manages customer relations with 6 valued members of Centria's elite dealer network, and he develops new relationships with prospective distribution partners. He is coming up on his 25th year at Centria, completing his 25th year. Brandon's generated over 135 million in sales and earned President Club status for outstanding sales 13 times, the President's Circle of Excellence in 2016, and achieved the company's highest sales volume in 2012. He's served as a member of Centria's insulated metal panel product development team. So he really knows his stuff, and he's also been on the sales team advisory council. Brandon is a longtime member of AIA, and he holds a Bachelor of Science degree in construction management from Eastern Michigan University. Brandon, take it away.
Thank you, Paul, and thank you to all the attendees. Today we're going to talk in depth about architectural insulated metal panels, and I emphasize architectural because it's more of a designer-based type presentation. So some really good pictures that we'll see, and just some different things that you can expect or start to design with when we talk about an architectural insulated metal panel. Paul, it's not advancing.
Try using your down arrow button on you clicked on the PowerPoint presentation.
Yes.
There. Well,
bear with me. I mean, I'll try again here. There we go. Should have switched. Did you see the second slide, Paul?
Yes, we do.
Oh, terrific. Okay. So some purpose and learning objectives. One, we'll truly take a look at an architectural IMP and really think about creative freedom and the ability to design with an architectural IMP. We're going to look at some performance requirements, function before form. Look how integrated components. I mean, integrated, we'll talk about windows and sunshades, louvers, and how they can truly integrate with the wall system. And then we'll also take a look at some code compliant, briefly, some environmental regulations, and we'll do some case studies as well. Go ahead with the video, Paul.
I'm going to have to change presenter to me so I can show the video, so sorry about that.
To understand the possibilities of architectural insulated metal panels today and imagine tomorrow, we must first take a look back. 25 to 30 years ago, metal provided architects with unique performance in a single panel, along with new distinctive aesthetic possibilities. While their imaginations were boundless, metal's fabrication, manufacturing, and installation capabilities were limited. The result was often flat, monotone facades with vertical panels as the design trademark of the 1980s to the 1990s. Architectural designs today continue to evolve with even more advanced performance capabilities, and the design potential of architectural insulated metal panels is virtually limitless. Elegant curves carve gently flowing sightlines. Bold colors capture the eye. Sharp corners create clean, seamless transitions. Profiled panels create distinctive relief. Architectural IMPs also complement other facade materials. So the question is, if all of this is possible today, what will be the design and performance possibilities for the insulated metal panels of tomorrow? Let's explore the possibilities and discover what's next.
Now, Brandon, I need to make you presenter again. And we're all set.
Great. Well, it's not working appropriately, Paul. There we go. Sorry. So as we look at the architectural insulated panel as a true solution here, let's go down to the basics. So really an IMP or insulated metal panel consists of two metal skins. And when we talk about an architectural panel, the exterior skin is usually at least a 22 gauge G90 galvanized or heavier for architectural flatness. And then the inner gauge, or what we call the liner side, is usually lighter, 24, most are standard 26 gauge. And then in between is a polyisosanurate, sometimes a polyurethane foam that binds the two skins together when we call it poured in place. But this, once fully put together, it creates a solid wall panel. And we'll begin to take our journey here. There you see the exterior skin, the foam core, and then the interior skin. But way beyond today, what we used to think of with insulated metal panel in general. I love this picture here because it shows the soffit. And the soffit, those are architectural IMPs. And the benefit there, and we'll talk about spanning capability a little bit later on, but an IMP can span pretty good distances, not uncommon for it to span 6, 8, or even 10 feet between supports. So as you look at that soffit there, you can only imagine if you were trying to do that with little 12-inch wide pieces and have a complex stud framing system up there, that could add an awful lot of cost and an awful lot of panel, where it was easily achieved with half the framing and some large IMP panels. So just a really good use of a soffit material. If we take a comparison to, I would dare say, maybe a competitive type of panel, most often we're compared to, or an IMP is compared to, a metal composite material, or maybe an ACM. So let's just take a quick comparison look at this chart. The assembly, if we break it down, a metal composite material, the manufacturers of those types of materials, and I think you're all aware of some name brands, they basically make a plank, and the plank for shows up in 4-foot by 8-foot sheets, or maybe 5-foot by 12-foot sheets. But then those planks are sold to a regional fabricator, and then the actual regional fabricator routes and returns those planks into their own local system. And those local systems are what really is what has to be tested per the testing criteria in the specification, not the plank assembly itself. So if we go to an architectural IMP, it's a complete system. Just like I showed you a couple of slides ago, it's 2 skins with the insulated core already assembled. That wall panel comes ready to put on the wall right from the manufacturing facility. If we go down to the rear, a metal composite material, or ACM, is truly a rain screen, meaning that you're going to need a backup system behind it to keep the weather out of your building. So you have your metal panel rain screen, and then you're going to need insulation, and then you're going to need an air and also a vapor barrier behind that. Whereas an architectural IMP, that is all built into the panel. So an IMP by design is meant to be installed right over stud framing or tube steel or even a pre-engineered building without the use of a backup system. It's a weather-tight system. And as the next two components I just explained, water tightness, when we talk about metal composite, is going to depend on the water barrier. Usually it's a peel and stick or maybe a spray applied that's applied to an exterior gyp board, where again, the IMP, it's built in. The same could be said for the air and vapor barriers. Those also have to be applied to an exterior gyp board or something similar. And again, the IMP, it's built right in. When we talk about code requirements, it gets a little sticky with the NFPA 285. And that basically every building over 40 feet in height or in multi-story buildings, we have to be in compliance with NFPA 285. And depending on the product that you're using with the metal composite material or ACM and the subsequent backup materials, there may be some issues in being in compliance with 285. I say here, most insulated wall panels, most of them on the market today, are in compliance with NFPA 285. But it's always best to check while in design with the manufacturer as to how they meet the NFPA 285 criteria. And then finally, warranty. There's very little system warranties. I don't know of any system warranties with a metal composite material. So you would basically be asking those 3 or 4 systems, the air water barrier, the insulation, and then the rain screen to give you a 1 warranty on the wall for all that. Where an insulated metal panel, weather-tight warranties are certainly available, upwards of 10 years. So you can get a warranty on your wall system, a weather-tight warranty for up to 10 years. Why can't it be or should it be the preferred solution? Well, it's an all-in-one performance. One, we're taking a lot of design out of the system. We don't need to build that backup wall. It's just panel over studs. One single installer can apply that panel to the framing instead of maybe multiple with a rain screen system. And then I'm going to show you or demonstrate to you in the next several slides just the aesthetic possibilities that you have at your disposal with an architectural IMP. Here's a great picture of a truly curved insulated wall panel. If we dig in a little deeper, panel modules on most architectural panels, we can make a panel 10 inches wide all the way up to 40 inches wide. So the idea of being handcuffed with a 24, 30, or 36-inch wide panel just isn't true. You really need to think in customization when we talk about these types of panels. Panels can be flat and smooth, and we look at length limitations typically up to about 16 feet long with that. And if embossed panel, truly embossed, panels can be made up to 34 feet long. So we can travel great distances and get a building enclosed very, very quickly with these panels. Beyond that, the ability to design variable reveals are available. I'll show you some profile panels coming up that are kind of plug and play. It's nice that the panels can be vertical or horizontal in their orientation. And then we'll talk again about the integrated components. But today, the palette is is great when we talk about architectural IMPs. Office buildings for sure, that's probably been the staple for nearly 40 years of applying these panels on office buildings. Education, K through 12, from early childhood development all the way up to college level, universities use an awful lot of insulated metal panel. There's a great example of a higher education. I think you'd be hard pressed to find a major university today without an insulated metal panel on their campus somewhere. Recreational, and when we talk about recreational auditoriums and theaters and ballparks, stadiums and arenas, just about every, I think, NFL football stadium uses an architectural IMP in one form or another, and most Super Bowls that you've seen utilize IMPs. Here's Mercedes-Benz Stadium, which is just an awesome piece of architecture. Uses an awful lot of architectural IMPs as their weather barrier. Healthcare today, we see a lot of cutting edge healthcare designs. Metal breathes that look of technology and high tech in a place where patients want to come to get better. And so an awful lot of healthcare facilities, from medical office buildings to outpatient clinics to major patient towers, are using architectural IMPs. This actually coincides with the retrofit of an old Toys R Us store, believe it or not. Retail. Today we work with a lot of different retailers on branding opportunities and creating the right color for them, the right look that they want out of an insulated metal panel. Something that can be replicated over hundreds or thousands of stores. And of course, here, being in the city of Detroit, we're going through a major renaissance in the city, and mixed use and multi-residential is a big part of that renaissance. And we see a lot of IMPs being used on mixed use multi-residential. But the ability to combine materials, the juxtaposition of combining materials, it's rare that you see an all metal panel. It's rare that you see a significantly masonry or terracotta building. Today we see a broad range of mix of materials on a lot of different pieces of architecture. This building here on the right is a really good example of masonry, metal panel, curtain wall, all blending together. Something relatively new on the aesthetic side of the business would be these fins that can integrate into the joinery. So those are aluminum extrusions that can truly actually integrate into the vertical or horizontal reveals. But just take a look at that photo and look how flat and smooth those architectural IMPs are. This is a quick case study here of Essex County West Caldwell School in West Caldwell, New Jersey. Architect was D. Cara Rubino. But as a school of technology, served its students for half a century, and it basically needed a facelift. It was showing its age. It probably didn't have the R value it should have to be for today's code. And so it went through a $30 million renovation. Included a 2-story addition, front of the school, retro existing space to accommodate current and new curriculum, and creating an outdoor courtyard. So insulated metal panel, as you'll see in this picture and then the next picture, had a huge part in redefining what this school was or is and giving it, breathing really new life into it. And here's just an excellent example. Those ribbed, or that blue ribbed type profile panel, is actually an insulated metal panel. And those have the same joinery as the larger panels above it, and you can, and next to it. And I love to talk about curving these products. A lot of architects don't realize that you can actually take an insulated metal panel and physically curve it. And you can actually curve it down to about a 3-foot radius if need be. But that being said, the picture on the bottom versus the picture on the top, it's hard to tell a truly curved panel versus a faceted panel. And I bring this up here because these are conversations that need to be had early on in schematic design when we're starting to talk about budgets. And so the earlier you can engage a manufacturer's representative and talk about costing and really the design intent, a manufacturer's representative can really aid and save some design time by giving budgets early and assisting with that design. Can the project afford a truly curved metal panel, or can we facet it and give it a curved look at a lower cost? So just something to think about. But curved insulated metal panels can be applied to beam wraps and column covers, bull noses if we're talking coping pieces. So there's a lot of capability to curve an insulated panel and use it on your building. Here's another excellent look at multiple profiles. Again, all insulated, something you may have not thought that an insulated panel could achieve, but they certainly do. And keep in mind, you can use a panel that's 12 inches wide to give you that kind of board look, 18 inches wide. Maybe we're trying to replicate the look of a terracotta tile. So that paint finish right there simulates kind of a terracotta tile. And if you were able to touch that paint, it has the feel of a terracotta pot. So with an insulated metal panel, you can actually replicate the size of a tile and install it for a fair amount less than a true terracotta piece. And remember, that would be in the entire wall system without a backup. There's an awful lot to say about the finishes, about metal panels in general. And I will just give one word of caution. Be very careful when we're specifying finishes today. The paint business is very volatile. And if we do not specify the paint correctly in our specifications, we could be paying an awful lot for something we may not ever see or get added value out of, like a warranty. And what I mean by that is a lot of specifications arbitrarily get a paint finish specified with a clear coat finish. And that clear coat finish today, right now, will add several dollars a square foot to the wall panel. And many paint finishes do not require a clear coat. They don't add extra warranty time, and you never see it. So you could be adding tens of thousands, even hundreds of thousands of dollars to your project without something you're ever going to see. So again, just be really careful. Ask your manufacturer how to specify the paint system correctly. But that being said, paints today are beautiful. This on the Gateway project is a color changing paint. Depending on how the sun hits the panels, it will act as blue, it'll act as silver, and it'll act even as a purple hue. But micas and metallics are a staple. A mica is a true is a 2-coat finish. It's going to give you the look of, say, an anodized, where a metallic is a natural 3-coat finish and should be specified that way, and gives you more of an architectural sheen, almost automotive-like looking sheen. Moving on, certainly wood grain finishes are available today. Terracotta type finishes are also available. And of course, customization of paint. Customized paints are also readily available.
Brandon, I've got a couple of questions. If you got a moment, or do you want to wait?
Sure, go ahead.
One person is curious about where you would require or desire a clear coat finish on a panel.
Okay. When we're looking at bright colors, so if this is a really good slide to talk about that. So on that top photo there, just about every one of those colors, cobalts, reds, oranges, and those yellows will undoubtedly require a clear coat finish. And the manufacturer, whatever paint manufacturer, will probably demand it in order to get any sort of color fade warranty. So very bright colors, cobalts especially too, are really something to start thinking about when we need a clear coat. And I know we're talking about wall panels in this presentation, but probably many of you also design with metal roofs. And I think it's a really good value to investigate a clear coat finish on a metal roof that maybe you're using a darker color or a brighter color. Those roofs are subject to UV 300 plus days a year. And that's where you could really get some value out of a clear coat finish that you don't typically see, if that makes sense. The building on the bottom there is a dull tone and certainly would not require a third coat. So hopefully that answers the question.
I think so, and I got another follow-up of somebody asking about where do you find wood grain finishes for IMPs? Are provided by manufacturers or?
Say that again, Paul. Can you?
Yeah, I asked that poorly. Sorry about that. Where do you find, where do I get wood grain finishes?
Wood grain finishes are, I would venture to say that most manufacturers probably have a wood grain finish available. Just be aware that those are typically print coats, but they're very, very good today. That's a print coat finish. You would be hard pressed to find any sort of a repeating type of cadence within the print coat. But I would venture to say that most, or they should anyway, manufacturers should have an offering of wood tones, and they're going to vary from manufacturer to manufacturer for sure.
Thanks, Brandon. I've got some more questions, but let's continue on here. Thank you.
Okay. As we kind of move through the presentation here, the fact that we never have talked about the weight of a panel, but most architectural IMPs are roughly about 4 pounds per square foot. And at that weight, they can be applied to a lot of existing structures. And so the idea of retrofitting buildings, here this picture is an old picture of St. Joseph's Hospital. That was a very old hospital, obviously masonry, it is showing its age. And because of the weight of the panel is light, a lot of this facade was able to easily handle that new panel design. And so retrofit is a big market for the IMP business, taking an old building and making it look new again, also increasing its R value and also its weatherability. Here's the new picture, and this is of this hospital after it was completely retrofitted with architectural insulated metal panels. Just a completely different look. The lighting's beautiful, and patients have a beautiful place to come and get well. As we move into the integration part of the program, windows can easily be integrated. Now, you'd have to be working with a manufacturer that actually has an integrated window, but the window design would actually integrate directly with the head and the sill of the window. This detail here shows a vertically oriented window where the panel stops and starts, the window starts again. A better view of this would be a section through a horizontally integrated window. And in a horizontally integrated window, the window frame actually has the same joinery as the panel above it or the panel below it. So it's a seamless marrying of the two joints where you get a seamless integration. We'll carry that thought in just a second. Another case study would be Mercedes-Benz Stadium. I mentioned that several slides ago, but here's a stadium that was done several years ago. We've seen it on television many, many times, whether it's a national championship game in college football or it's a Super Bowl. 83,000 square foot, just a monster of a building, retractable roof. Panels reversible and lightweight to support the retractable roof. IMP panels were strategically slanted to cater to the retractable pendants. If you see these pendants, if you see it from above. And the IMP provides a thermal efficiency and moisture control when the roof is forced to be closed. And that, I think, we're starting to demonstrate that the actual true function of an IMP. The aesthetics of an architectural IMP, when we talk about continuing with integration, would be louvers. And did that come up, Paul? I'm sorry if it didn't. Did the section just pop up?
Yes.
Terrific. So this is a true horizontal application. You see the horizontal panel and section. The louver comes to the job site with the joinery already fixed to it. And now again, just like the window would be, it's a simple plug and play where that louver can seamlessly integrate. What you don't see in this section, or if we were looking in elevation, is extra flashing material. So you eliminate this box frame or picture frame of flashing that would go around a non-integrated louver. And one, it adds extra sight lines. Two, it adds extra caulk. And over time, it could certainly be unsightly, and probably some maintenance would have to be done to that type of a louver, just even cleaning up from the caulk. So this is kind of a no-brainer. What you find in the louver, the cost of the louver really offsets the cost of the labor when we're talking a non-integrated louver. So, and then there's a real good sill detail. Most louvers can be designed to be integrated, depending on your free area, your performance of the louver that you're looking for, storm resistant, bird screens, all of that can be designed. The depth of the louver certainly can vary as well. So there's this really interesting sunshade attachment that's really, it's not a normal penetration into the architectural panel. And so the sunshade itself is manufactured by others, like the louver is, but what you see here is a casting, and that casting is pre-engineered. So if we look at the panel there, the panel itself, the exterior face sheet is cut out and the insulation is also removed, but the backside liner is kept in place. And if you remember, that backside liner is acting as the air and the vapor barrier. So we're not taking that out. You would insert a thermal spacer. That's that first piece that would go back against the liner side. And then the casting itself, either a 4-inch casting or a 6-inch casting with simply just 2 through bolts. Those would be the only penetrations going back through the liner side of the panel. So we've kept that barrier, that vapor and air barrier practically intact, rather than hollowing out these big pieces. That could now receive a sunshade. This could also receive a piece of signage. It could receive some decorative item. It's used many, many times to hang something away from the panels, not just a sunshade. There in section, we see how clean it can be. And again, we're not looking at bulky flashing going around the penetration. Again, it's all pre-engineered aluminum that would fit right into that penetration. Translucent daylighting is also available. And you'll see, again, it kind of gets repetitious. The head looks very similar to the louver and the window, and the sill would also look very similar to the sill of a louver or a window. Again, these are pre-manufactured, shipped to the job site, and ready to go on the wall sequentially with the insulated wall panel. We looked at accent fins a little while ago going vertically. Here we see accent fins actually going horizontally. Very similar fin. Fins could be library shapes like this. It could be maybe customized as well, but truly could be integrated into the panel itself to give just a more architectural flair, if you will, to the design. Paul, this is another video, but I'm not so sure. Is it? Can you see it playing at all?
No.
Okay.
I didn't,
because of
it's not appearing as a video. Oh, there it is.
Okay. We're just going to maybe skip through this, Paul, because the last one, so we don't have to transition back and forth. But the video basically shows it's an animation showing a complete wall system, showing insulated metal panels and truly integrated windows, sunshades, and louver profile panels, all being part of one facade. So you could have the responsibility of basically 80–90% of your facade under one installer, one manufacturer, and be completely warrantable, offer a weather-tight warranty.
Brandon, animation is working. There's no voiceover on it if that was intended though.
Right, there's no voiceover. Now I just skipped. I'm to the next slide now, called Performance of Architectural IMP. Is that popped up?
Yes, you're on the
yeah. Great. So we've talked an awful lot about the pretty pictures and the design capability and the form that IMPs can take. We'll talk a little bit now about the function side of it. This video is playing. Is that one playing, Paul?
It is, yes.
Terrific. I'm going to let it finish. You'll see stud framing, and then you'll see insulated metal panel just going up right over the stud framing without any sort of backup. On the interior side, we show gypboard. That's fairly typical, but it doesn't necessarily have to be gypboard. That panel could serve as your interior wall application. And if we're looking at a laboratory or an auditorium or maybe a cafeteria or some sort of a lab space, many times the backside of the insulated metal panel is left to be the interior finish. When we look at span capability and we look at air and water infiltration and we look at FM requirements, the gang is all here. Any architectural IMP or any IMP worth its salt should really have a lot of these boilerplate testing as a part of their repertoire. ASTM 31 is an air test. The water test is the ASTM 330. I'll show you something here shortly. Those are pretty boilerplate tests that we see in specifications. When we talk about FM, we could talk an awful lot about FM today. FM 4880 and 82 are fire tests. There's load testing with FM. Again, I'm not going to get into the weeds with FM, but if your owner is requiring FM as a part of their design, then I highly recommend you get with your manufacturer's representative to discuss compliance with FM and what that might do to the structure behind that's holding up the panels. So there's a lot to talk about with FM, and that should happen very early in design. And then as far as the spanning capability, I mentioned earlier, that's not uncommon to see 10 feet from support to support. So can you imagine having a 20-foot long panel and only fastening it maybe in 3 places? That is a real, that's a real help, and it can be a real cost savings when we're talking about eliminating structure at 16 inches on center or 24 inches on center. So here we have the water performance. These are boilerplate type testing, and it's kind of interesting. And again, when we look at ASTM 330, there's a lot to talk about, because ASTM 330 allows the manufacturers to test with a perfect air barrier. And when we test with a perfect air barrier, we're really not testing the panel, we're testing the air barrier. So Paul, you and I could start building panels tomorrow, and we could take it and we could test it to ASTM 330. And as long as our air barrier, the barrier behind it was perfect, we could easily pass this test. And at 6.24 pounds per square foot, just not a lot of meat there. We should be testing it at greater values, at 15 pounds per square foot. And we should be breaking the air barrier, or that air barrier, and trying to bring water into our building while testing it. Now we're testing real world conditions, and that's when we're going to get into the AMA testing, the 508 tests, more substantial tests with teeth. And so I highly recommend adding the AMA 508 tests to the specifications, because it's more real world. Here about the air too, we can talk about the air, but 0.04 CFM at 1.57 just really isn't very much when we're testing. Like, something worth its salt really should be at 0.04 CFM and at 6.24 pounds per square foot. A little bit more substantial, or equates to a 50 mile per hour wind load. And we talk about IMP foam versus mineral wool. And mineral wool gets used an awful lot today as a backup system to rain screens. So if we go back to the ACM panels that we talked about, or the MCM panels, a lot of those today are designed as over top of mineral wool. Where here the architectural panel on the left-hand side, again, would be a single wall element by itself. Coincidentally, what you're seeing there on the right-hand side is a metal panel, is an insulated metal panel with mineral wool sandwiched in between it. It is typically, it's an insulated metal panel, but instead of using a polyisosanurate, it's actually using mineral wool. Mineral wool is an excellent fire retarder, and a product like this could be used when we're really trying to create an hourly firewall. But if we look at the mineral wool itself, the bare mineral wool, it's pretty heavy. It's 8 pounds roughly per cubic foot. And the R value suffers, 3.6 R per inch versus a polyisofoam foam rather, that is you're going to see upwards of 6.7, 7.3. Some manufacturers today even advertise 8 or 9, depending on what testing you're looking at. The weight is less than half of what a mineral wool panel would be, and it's a closed cell foam, and closed cell foam doesn't absorb water. So when we talk about R value, the mineral wool is considerably less per inch. When we talk about weight, it's 2.5 times heavier than an isofoam panel. And when we talk about water penetration, mineral wool is not thermally efficient when it's wet. It really has to be allowed to dry so it can maintain its R value, versus a closed cell foam that doesn't absorb water at all. As we kind of turn the corner here and head for home, some quick sustainability benefits about using an insulated panel. One, halogen-free foam is definitely available today. Smaller embodied carbon than precast or concrete and brick. Made from 60% scrap steel, so a very high recycled content in an insulated metal panel. And again, high R values as high as 9, and the U factor as low as 0.014, depending on the test that you're looking at. And what I mean by that is that ASTM 519, or if it's ASTM 1363, those will offer different R values. Each manufacturer should have an R value associated with each of those tests, just for your information. And then less job waste. And what I mean by that is, if we were building a rain screen wall, you would have gyp board. The gyp board is cut to fit and the scraps are thrown in the dumpster. Then you would have an air and vapor barrier, depending on which product it is. That has scrap, that has packaging, that all ends up in the dumpster. And then you have insulation. The insulation is cut to fit. The packaging, all of that, the scrap ends up in a dumpster. Where if you use an insulated metal panel, all of that goes away. None of that even comes to the job site. And so inherently, you're saving all those vehicle miles traveled, and you're saving all of those products from even entering the job site. So it's inherently more green to build with that type of a product. The future is pretty bright. When we talk about architectural IMPs, halogen-free foam is actually here today. It is available. It's safer for building occupants, containing no HFRs, which can be toxic to humans over time, healthier for the environment, and gives off fewer emissions of halogens. And the industry is constantly looking at giving the architect more freedom of design, whether beautiful paint finishes that change color, profile panels, vertically integrated window design, the branding opportunities that I mentioned. If you work with a major supplier or brand, manufacturers can certainly work with you in developing paint systems and metal panels that are specific for your brand. And here we've made it. And I'll be happy, Paul, if there's more questions to take, I'll be happy to take those questions right now.
Thanks, Brandon. We do have a few questions that, let me start out with this one. You mentioned that IMPs can be used for retrofits. How are IMPs attached in a retrofit situation?
They can be attached a variety of ways. Most retrofits that I see are going to go over existing masonry or some sort, or maybe it's existing precast. And if that's the case, heavy gauge hat channels or Z-girts or even tube steel can be applied to the existing facade. And then the metal panels are hung from those Z-girts, hat channels, tubes that way, if that makes sense. Engineering can be involved. Again, you would place some of these maybe every 4, 5, 6 feet apart, depending on the layout. And all those pieces and parts could be done or engineered and supplied by the panel installer. So you would simply show placeholders on your drawings, and then the metal panel installer would be responsible for the engineering and placement of the product. We just finished one here in Detroit where the whole facade, it was a curtain wall that failed over years, and the curtain wall was stripped, and we went right back to the concrete slabs and the red iron. And in that case, vertical tube steel was applied, and then the panels were run horizontally across those vertical tubes. So there's different ways. Hopefully that answers the question.
I think so. Excellent. All right. This one I think is a curious question, and I'm interested in it myself. We see lots of IMPs used in multifamily construction. There's not much used at all in residential single-family construction. And this person is asking what the current role of IMPs in single-family housing, especially looking at modular home construction. And then he has another question here. What's going on to get IMP code approval so they may be used nationally? And I think specifically to modular housing.
Well, to answer the first part of the first question, usually it's cost that holds back IMPs from being used on a single residential homes. Metal panel, it can be very efficient, but the quantities of the panel have to be there. And usually a single family home only requires maybe 1,000 or 2,000 square feet of wall panel, if that. And it really becomes pretty expensive to design with. The details as well, because of the scale of a single family home, you start, the details become a little bit more finicky. You see a lot more flashing just because of the scale of it. So the flashing that may be used at a residential window would become more obvious, or maybe at a corner or at a soffit. So for those reasons, we don't see them yet use individual single family homes. Now, when you speak modularity, that's where the future is. Modularity of office buildings, modularity of schools, modularity of residential homes. When we could mass produce something like that, and you're buying in bulk from the manufacturer, then we've really got something as far as cost is concerned. So for those reasons, I think that's why where we are, we're kind of the stalemate right now until the modularity really starts to take off and manufacturers can work, IMP manufacturers can work with the manufacturers of the modular homes or schools or offices. So the second part, I guess what testing or what approvals do you think are they looking for?
See, I was curious about that too. I'm not quite certain what approvals would be needed for modular housing, but it sounds from your description, the bigger issue is just the market forces don't make it an efficient a product there. It's designed to cover large areas of wall space.
Yeah, cost and detailing on that type of the size or scope of a single family home. We've done it. I think in my 25 years, I think I've seen maybe 2 of them done, or small, very small offices done with IMPs. So it can be done, and it has been done. But until we get to more mass production, I think that's what we're waiting on.
I do have a couple more good questions here. If you're using IMPs, and I know we're talking about walls today, but if you're using IMPs in a roof system, would they support solar panels?
Really good question. And we could talk about IMPs holding up anything. And the rule of thumb is that an IMP really won't hold anything. And what I mean by that is that anything that's going to be secured to the building, whether it's on the roof or on the actual wall, really needs to go back to structure. So we never really want to physically attach anything to the face sheet of the skin, because over time with wind loads, it will eventually either pull away through pull out. It's only 20 or 22 gauge sheet metal. The fastener will eventually pull out, or you could delaminate the skin from the insulation. So I caution you never to fasten anything directly to the insulated panel, whether it's a signage or if it's solar voltaics.
You could
you need to through fasten, absolutely. You would through fasten back into structure.
Yeah.
Yes.
Are there
and that's where those castings that we talk about, that I talked about, that's an excellent piece to use on the wall side for a penetration to hang signage.
I was curious about, do those castings affect kind of the continuous insulation benefit of IMPs, or cause any problems for thermal bridging? Because
they really don't. They really don't. They're very infrequent. They're few in between. When we talk about continuous insulation, that's a whole nother presentation, but there's really 3 ways that you can pass ASHRAE 90.1. You can use continuous insulation over all the framing members. You can use the minimum R value, where you build the R value through the wall system with bad insulation, and then a continuous CI on the outside of the wall. Insulated metal panels use the reciprocal of that, and they use the U factor because we're an assembly. So I can tell you that IMPs are in compliance with they're in compliance with ASHRAE 90.1, and that's all you really need to know when we talk about that in regards to continuous insulation.
Brendan, you
That's
mentioned
a good question.
Yeah, you mentioned about the solar panels, the potential for wind uplift on them causing problems. And I have a question here about wind load. And is there a rating for hurricane-prone areas for IMPs? Any special provisions the industry has provided for IMPs in hurricane-prone areas?
There absolutely is. Florida product approval, hurricane rating, that's going to be by manufacturer. And Paul, it's going to, and some manufacturers have that rating, some don't. I can tell you that it will vary from product to product in the gauges of the material that's used, the thicknesses, and the fastening frequency of how the manufacturers pass, say, Dade County or get Florida product approval. Those are really, really specific. And again, consultation with the manufacturer should always be done when we're talking about that. But short answer is yes, they are available.
Great, thanks. Another good question here is one of your slides has a picture of an IMP fastened directly to a metal stud, and on the interior is a gypsum board. And this person asking, is there a vapor barrier needed, or is that the liner take care of that? And if so, where would it be in the assembly?
No, the insulated metal panel is the entire wall. Okay. So the liner side acts, it's impermeable, acts as an excellent vapor barrier, as well as an excellent air barrier. I will caution you that the installers of architectural panels should be trained and have several years under their belt, because you do have to marry the air barriers from panel to panel, and at a vertical joint, the air barriers have to be married together. There's very basic details that are available, and it's been done for 30 plus years, but the installer really has to know what they're doing too, and you have to have a manufacturer that's willing to test it or warranty it. I will caution too, we really don't advise putting batt insulation. In that video, you saw that the stud cavity was empty, and that's for good reason. We really don't want to put added batt insulation on the back side of that vapor barrier. That's the warm side, and if you add batt insulation, we could be pushing the dew point inside the cavity of the wall. So again, it's wiser to use just a thicker wall panel. If we're looking for more R value, you could use instead of using a 2-inch, you could use a 2.5 inch. Instead of using a 2.5 inch, you could use a 3-inch wall panel to get your R value. If it's absolutely necessary, most manufacturers can do a condensation resistance factor kind of test and tell you exactly how much insulation you could put behind there. But again, I would just leave it out if you can.
I think that's a good segue to this next question, and let's call this the last question about retrofits where you're hanging IMPs on hat channels. Would a thermal break be necessary in that circumstance?
Not usually, because the masonry itself acts as the thermal break. So it's no different than that masonry being exposed for the last 30 years to the environment by itself. So the actual hat channel or Z-girt or structural piece gets fastened into the masonry or the precast only. It doesn't go all the way through the walls, so you shouldn't have any transfer of thermal. Retrofit is a unique animal, and it gets done an awful lot. We just have to pay special attention to some of the details, that's all. Not all of them are typical.
Brendan, I know you have a little bit more you wanted to talk about here, but before we move on to the next section of this, I want to thanks for a great presentation. For those who are listening, you can follow up at centria.com to get more information. Reminder, AIA credits and certificates will be handled automatically. Give us 7 to 10 business days. Somebody asked whether there's a recorded version of this webinar. There is, and it'll be on our website, metalarchitecture.com/webinars. Our next webinar is Thursday, August 24th on metal roof systems, design and installation considerations. But Brandon, you have a little bit more you want to talk about? So why don't you?
I do. Thank you for the opportunity. Yeah, so we've concluded the AIA portion here. I just want to briefly tell you a little bit more about Centria, if I could. We're a company that really believes in function and creating buildings for long term. We have products for that, both non-insulated and insulated metal panels. These are some pretty interesting looks, but a big market today is using an insulated metal panel as your backup wall system. So here in the sphere here, you see insulated metal panels going up right over tube steel framing. And that tube steel framing then is holding this IMP. That will be the entire weather barrier. This is a product we call metal wrap. And the exterior rain screen simply then with a hat channel will get affixed to that metal wrap panel. It's being used more and more today. We can put metal over the top of it. We can put masonry over the top of it. We can put just about any rain screen you want could be applied over metal wrap. An insulated metal panel backup system. And coincidentally, this is also warrantable with just about any product over the top of it. Just a really quick way to get your building enclosed. A building like this has liquidated damages, and this allows the interior fit out to start at a very quick pace. Once the building is totally enclosed, it is weather tight for the long haul. This is our architectural panel that I spent most of the program discussing. Form wall insulated metal panel, that's what it is. It's a 40-year-old product. It's been around forever. It truly is designed to go over stud framing without any sort of a backup. You see a glimpse there of a metal vertical joint. We don't deal in gaskets really anymore. It's metal and it's insulated. It's vertical, it's horizontal. The color scheme is beautiful.
Let me make myself presenter and we can.
That's okay. I'll skip. Oh, okay. I was going to skip the video, but it's up to you.
Well, you stay on as presenter then, Brandon.
Okay. Formal Wall Graphics Series is also an insulated metal panel. It's the same Formal Wall Dimension Series, but it allows us to put false joints in the panel. So it can give you the look of a grid, or it can give you the look of many panels, but just using a single panel. So take, for instance, you could take a 20-foot long panel and you could put 5 4-foot false joints in it to make it look like individual 4-foot panels. You gain an awful lot of labor savings with that because you have the same couple of people in the field putting up that 20-foot panel, where if those were individual panels, it takes those same 2 people to put up that individual 4-foot or 5-foot long panel. So a tremendous labor savings. It's a design criteria called graphic series, and believe it or not, it gets used an awful lot. They could be offset too, so you could have a running bond pattern to really play with the wall. This is a little bit more about metal wrap. The metal wrap there, that greenish panel is kind of a dumbed down version of formal wall. We use light gauges, and it uses an integral subgird. That integral subgird is strong enough to then hold your rain screen. If you look on the right side of it removes all of those pieces and parts of a typical backup wall system. the rigid board insulation, the air vapor barrier, and the gyp board. And so it's a much more simple application, quick weather in, and warrantable. And here we talk about the metal vertical joint, just a cleaner approach. The gaskets will not fall out of the vertical, and that vertical joint could be painted the same color as the panel. It could also be painted a contrasting color. Here's a metal wrap product going up. This is a little bit of an older version of it, but you see the subgirts, they're attached back into a piece here. And then this is just a simple rain screen that goes up over top. But this is all weathered in, this building is, and you can start gyp board and everything else you need. And in the end, it all gets covered up. So there we see, looks like some aluminum composite, some profiled metal, and then some more profiled metal over here. There's a better look at metal wrap, and that subgirt is 16 gauge, so it's very heavy. And then the subgirt for the auxiliary panel, or the rain screen panel, just simply attaches right to it. The subgirt within the joinery goes back into the stud, and that's our structural source now to hold up your exterior wall. It could go over vertical, it could be horizontal. This looks like a pre-engineered type building. So metal wrap has an awful lot of uses. Just here in Michigan, I've got over 1 million square feet in place. So it's not going anywhere, and the advantages are quickly being understood by the design community and also the contracting community to get their job done quickly and warranted. And then finally, the last slide here is just some of the more custom applications that Centria does. Most of our panels can be turned seamlessly. We call it micro seam corner. You could also use extrusions. Many of our products have extrusions available for corners and sills and copings. And then we can curve a variety of panels. And we have profile louvers. So we can make a louver blade that looks very similar to the actual wall panel. So we can actually try to hide the louver as we go from true metal panel over maybe a louver opening. So, well, that's really it. Thank you for your time. Thanks for the help, Paul. Much appreciated. Is there any questions of those that are left that I can answer regarding products or Centria?
Most of them are compliments on the presentation and where can they get a copy of it. So we'll follow up on that stuff. So, but Brandon, great presentation. Thank you very much. And thanks all for sticking around with us and have a great week.
Thank you, Paul. Thank you, everybody.